Hello everybody, it's Patty Lager from Patty Lager ND, and today I want to review with you all the kidneys and a little bit about the urinary system. If you like this video, please check out my full human anatomy and physiology course that I offer online, and the link for that is in the description below this video. Okay, so here we're looking at the kidneys within the human body. This picture is actually highlighting the major organs in the urinary system. So using my pointer here, you can see we have two kidneys. Notice that the right kidney is a little bit lower in its position compared to the left. And that's because we have this huge organ not shown in this picture called the liver that takes up most of your right upper quadrant. Leaving the kidneys, we have urine that exits medially in these two little tubes called the ureters. These tubes carry the urine to your urinary bladder where the urine is stored, and then when we're in an appropriate location, we release the urine through the urethra, most commonly in the toilet. So those are your major urinary system organs, and what is it that the kidneys actually do? So let's take a look at the kidneys a little bit more closely within the abdominal cavity. The kidneys, being very important organs, are quite protected. They're actually nestled in the posterior compartment of the abdominal cavity. They're actually behind a tissue called the parietal peritoneum. And so we describe the kidneys as being retroperitoneal. They do have several layers of cushioning surrounding them, including a layer of fat. We call that the perinephric fat. And all of this protective layering really helps to make sure that the kidneys are not going to be damaged by trauma. Posteriorly or behind the kidneys, we do have the lower ribs as well. We see here in the abdominal pelvic cavity in red, this is the abdominal aorta, and it carries oxygen-rich blood. We see in blue the inferior vena cava. It is blue because it's carrying deoxygenated blood. And so when we talk about traditionally the role of the kidneys, especially in the courses that I teach at the college level, the textbooks are really focusing on the function of the kidneys in filtering the blood. I'm going to show a little bit about the other major bodily fluid that also needs to be cleansed, and that is the lymph, and we'll talk a little bit about that towards the end of this video. But this picture is just showing the blood, and that's really what most textbooks focus on, how the kidneys filter the blood. The kidneys have a lot of other functions as well. They produce several hormones like erythropoietin. They produce the enzyme renin, and renin gives rise to another very important hormone called angiotensin II. So the kidneys do play a role with erythropoietin in helping to stimulate new red blood cells, and in the case of angiotensin II, with helping us to raise our blood pressure so that it doesn't drop too low. Because traditionally, having low blood pressure has been more problematic for humans compared to high blood pressure. So most of the hormones in our body actually raise blood pressure. There is one set of hormones that actually lowers it, and you learn a little bit more about that in my course. We see the cute little adrenal glands. Sometimes they're referred to as the suprarenal glands. Those sit on top of each kidney. And just to kind of give you an idea about the size of all of these organs in humans, the kidneys are about the size of a bar of soap, and our adrenal glands about the size of a walnut. So they're not very big at all. Branching off of the abdominal aorta here in red, we see also in red the renal arteries, and then in blue the renal veins. So the way the blood works is that we send blood into the kidneys by way of the renal artery. Here the blood is filtered, and then leaving the kidneys, the blood exits by way of the renal vein and passes into the inferior vena cava. This is what the kidney looks like when you cut it with what is called a frontal section. So we're just kind of cutting it in a frontal, or also called a coronal section, kind of this way, okay? And you kind of open the kidneys up like a book, and now we can see the interior of the kidney. The kidney has an outer cortex, And then it has an inner medulla. The medulla is made up of these triangular shaped structures called renal pyramids. And in the area of the renal pyramid and the cortex region just outside of the renal pyramid, we have tiny little structures called nephrons. And nephrons are the functional units of the kidneys. These are the filtering units of the kidneys. The nephrons empty a fluid called filtrate into tubes called collecting ducts, and all of the collecting ducts merge at the tip of the renal pyramid. And here, this is where the fluid called the filtrate leaves the collecting ducts and then is collected right here into what is called a minor calyx. There are several minor calyces here. And once the fluid hits the minor calyx, we now can call it urine. And here the urine then will leave through the minor calyx into a major calyx and then into the renal pelvis. From the renal pelvis, the urine is carried away from the kidneys through the ureters. You can also notice here between the renal pyramids we have what are called the renal columns. And the columns do allow for the branching of the blood supply within the kidneys. Now, I mentioned the nephron was the functional unit of the kidney, and this is really what the nephron looks like. The nephron, these are microscopic structures, so we cannot see them with the naked eye. But we do see a blood vessel right here. This is a little capillary bed called the glomerulus. And this is the blood vessel where the blood is actually filtered initially. And it basically is filtered based on size alone. So anything small enough to escape the blood, because the blood is under very high pressure in the glomerulus, it all leaves the blood and is collected by a little sac called the glomerular capsule. When I was in medical school, we called this the Bowman's capsule, but glomerular capsule is now the new name. So the glomerular or Bowman's capsule collects the filtrate, and then this passes on to coiled tubing, and collectively all of this coiled tubing is called the renal tubule. That's kind of another component of the nephron. It has several different segments like the proximal convoluted tubule, the nephron loop, which traditionally used to be called the loop of Henle, and the distal convoluted tubule. And as the filtrate, which is the fluid that was collected from the blood, as it passes through this tube, notice these little arrows. Some of the arrows are pointing out, some of the arrows are pointing in. Here we're signifying that we're still modifying the filtrate. So if we want to take additional substances out of the filtrate and bring it back into our bodily fluids, bring it back into the blood, we can do that because really we filter a lot out of the blood in all of these little glomeruli. On average, we filter 180 liters of substances, including water, out of our blood every single day. So think about that, 180 liters. You know how big a liter bottle is. Multiply that by 180. That's how much our kidneys are working. That's how much we're filtering from our blood on a daily basis, okay? Does all of that become urine? No, it doesn't, because if it did, we'd be in the bathroom or we'd be somewhere hiding, going to the bathroom constantly. So no, we don't produce 180 liters of urine. On average, we produce about 1 to 2 liters of urine. That's kind of a normal, healthy range. If we want to be clinical, 700 milliliters to 2 liters is what's traditionally considered normal urine output. So a lot of what we filter out of the blood is actually taken back into our bodily fluids, leaving again only 1 to 2 liters on average left over. And that's what leaves our body when we urinate. So we see right here this renal tubule still modifying, taking a lot of the substances back into the body, back into the blood. Some stuff comes into the filtrate later on, a lot of over here. Notice that these arrows have a little dash. That's to signify that they're under hormonal influence. So we have hormones that can specifically cause the reabsorption or secretion of specific substances, mostly here in the distal convoluted tubule or the collecting duct. To give you an example, hormones like aldosterone. Aldosterone is a hormone that the adrenal glands secrete, and this hormone targets the kidney. Specifically, it's targeting the distal convoluted tubule, triggering the reabsorption of sodium. And water tends to follow sodium, so it also helps to trigger the reabsorption of water, and that can help to raise our blood pressure. Parathyroid hormone actually targets the distal convoluted tubule, triggering the reabsorption of calcium. So this pulls calcium out of the filtrate, bringing it back into our blood. What other hormones? Atrial and brain natriuretic peptides. They too trigger, or target, I should say, the distal convoluted tubule, and they actually oppose aldosterone. They trigger sodium secretion. So, or I should say, I think the newer research indicates that they prevent the reabsorption of sodium. So they keep the sodium in the filtrate. So we're not going to be reabsorbing sodium when those hormones are influencing the kidneys. And then we come to the collecting duct. The collecting duct, all of the collecting ducts that receive filtrate from all of the nephrons, they all merge at those renal papillae, which were at the tips of the renal pyramids. And here the filtrate will then enter into a minor calyx, which will then refer to that as urine. But notice here at the collecting duct, again, we have little dashed arrows to signify that this is under hormonal influence. The hormone here primarily is called antidiuretic hormone, and this is a hormone the pituitary gland secretes, and it triggers the insertion really of these channels called aquaporin channels. That helps us to reabsorb water, and I get into that in more detail in my class. There's the whole countercurrent multiplication system that we talk about in the chapter over the urinary system. But lots of hormones will target the kidneys and influence kidney function. Here's another representation of several different nephrons. These are in the renal pyramid and that cortex region just overlying the renal pyramid. There are blood vessels called the arcuate arteries and veins. The arcuate artery is in red, the arcuate vein is in blue, and that is basically the area where we go from the renal pyramid, which is in the medulla, to the outer cortex. And you can see that in this nephron, most of the nephron is in the cortex, so they call these nephrons cortical nephrons. These nephrons have a very long nephron loop that delves deep into the medulla, so they refer to these as juxtamedullary nephrons. And in purple, these are blood vessels surrounding those nephrons, primarily surrounding the renal tubule component of the nephron. And again, when we reabsorb or secrete things from that filtrate that's passing in the little squiggly tube, which is part of the nephron, if the substance is being reabsorbed, it's being pulled back into the blood. And these are the blood vessels that it's being pulled back into. In the cortex region, we call these blood vessels peritubular capillaries. In the nephron loop, they're more specialized and they're called vasorecta, and they play a role in that countercurrent multiplication system. We know that after the filtrate is modified in the renal tubule, then it passes into those collecting ducts. It can still be modified by hormones like antidiuretic hormone that can help us reabsorb more water, especially in situations where we're becoming a little bit dehydrated and we can't afford to lose excess water in our urine. So this is our last ditch effort to pull a lot of that water out of the filtrate before it does become urine. Now, the last image I want to highlight here is something I've shown in previous videos. And this is, I found this in a research article. I will link that research article in the description under below. This is showing the blood supply. We can see V is vein and A is artery. It's showing parts of the nephron. So we have the renal tubules and the Bowman's capsule. Okay, so those are the components of the nephron. But in addition to that, notice we have the letter L. And L is standing for the lymphatics in the kidney. So one thing that Dr. Morse talks quite a bit about is that the kidneys filter lymph. And we see here a diagram of an artist representing the lymphatics within the kidneys. So, the way I teach it to my traditional pre-allopathic healthcare students is that the kidneys have a main function of filtering the blood. We have no indication that, in the textbooks that is, that the kidneys are filtering the lymph. But we do see some scientists are showing the importance of the lymphatics in the kidneys. And is there anything that we could maybe go into a little bit more detail about, or maybe further research to indicate that the kidneys are filtering the lymph? As Dr. Morse discusses, the lymph is our bathroom, whereas the blood is our kitchen. So, the kitchen is delivering food, delivering nutrients to all of our cells. And then we have waste products that accumulate. Some of those wastes do get picked up by the blood. Okay, there are waste products like creatinine and lactic acid, things like that you can actually, if you do a blood draw, find these wastes and measure their levels. And we often see in a blood work that a doctor might order, we can see, what levels you have of those certain waste products. But a lot of the sludge, a lot of the other nonsense that cells produce and actually build up in cells because of unhealthy diets or stress, a lot of that too has to be taken away from the tissue spaces. And it's the lymph that's really taking that away throughout those lymphatic vessels and carrying that away from tissues, because if it stays within the tissue spaces and it's congested there, it traps additional acidic waste products, and that leads to inflammation. Chronic inflammation then leads to tissue change. And it's at the tissue change level that's when people are experiencing the symptoms, and if they traditionally go to the doctor, they'll get some diagnosis to suppress those symptoms. But in Dr. Morse's teachings, what we're saying is that you don't want to suppress. You need to clean. You need to detoxify. Here we're showing, again, the kidneys and the lymphatic system in this microscopic diagram. My job here is to go into further detail about what the connection is between the kidneys and the lymph. I've made other videos about that, but I'm just including that in this video about what the kidneys do. So I hope you enjoyed this educational video. If you want to learn more about the human body, please join my course. The link is in the description below. I also do consultations one-on-one. If you'd like to work with me, I do ask that you initially sign up for an initial consultation, and then we do follow-ups afterwards. I do an iridology reading where I look at your iris and we look at where you are right now, and I explain all of that to you. I actually give you a PowerPoint handout that discusses my findings on the iridology report that I will also show you on our Skype consultation. So if any of this is of interest to you and you want to learn more, or you want to take charge of your health, please, I'd love to work with you, because during our consultation, I want to educate you. That's my primary job. I'm not here to prescribe or diagnose. All I want to do is empower you and help you learn about what your body's doing and why you're experiencing the symptoms you are, and what you can do to help your body get rid of those naturally. Have a wonderful day, and I will hopefully see you all soon.